Next up, we have Jerry Chu, who's going to talk a little bit about some of the experiences with Open vSwitch, both implementation and, I guess, deployment. So here's Jerry.
Hi. Sorry for some technical hits. First of all, a bit of a disclaimer. I'm a relatively latecomer to OVS. I got involved less than a year ago. I'm also relatively new to virtualization. So some of the stuff, I will show you slides. I have a lot of the good and bad and ugly. Long list of bad and ugly, not a lot of good. But actually, OVS, I think I have a very positive experience. And also some of the bad part, again, you guys probably, many of you probably know OVS history and the latest architecture and latest code better than I. I've been playing catch up, having followed very closely to the vSwitch.org. So some of the bad actually has been fixed or being actively fixed. I just noticed this recently. And before I start, I want to actually make sure that, although I'm the one who's presenting the slides, much of the work has been done by my colleague, Bill Summerfield, working on the kernel, and Jing Ai and his team on the user side, and Patrick has done a lot of test framework setup. So first, the good. So basically it works. When I got the download the OVS, the user kernel, and set it up late last year, it's pretty easy to use. There's this L2 learning mode that doesn't require a control plan. So I got up and running very quickly, and recently I checked the recent code base on the upstream Open vSwitch.org. It supports more and more encapsulation protocol and has a lot of features being added in the past year. One question I have is I think the OVS, if I'm correct, it's pretty much married with OpenFlow, right? And OpenFlow is maybe one of the most dominant control plane protocol, or there are a few alternatives. But one alternative at least the alternative effort outside of OpenStack and OpenFlow is happening in IETF. So my question to the audience is, if IETF come up with something different, the MVO3 working group, I don't know if anybody is involved in that working group at IETF? Okay. They are doing something from ground up. And if they do come up with something new, I wonder if the OVS can be adapted to a new control plane protocol. And also, OVS performance is reasonable. I would say reasonable. The latency performance, if I just measured how much the OVS kernel module, assuming the flow setup has been done, the module itself introduced in terms of latency. Oops. Tom. Sorry. Sorry. I can continue to talk. It's less than 10%. Pretty good, but I have to keep tapping, I guess. Yeah. The less than 10%. Super difference. Super performance is another story. Pretty much super tied to all the offloads, or software optimization. I have a later number showing the what I got recently. Now goes to the bad. Okay. Basically, it seems like there are two. So most of the Linux kernel guys work on the upstream kernel from kernel.org and various Git. But OVS actually has its own, the most recent changes are in the openvSwitch.org. And I have been wondering why, I kind of, number of reasons I can guess, maybe openvSwitch.org is kind of staging a repository, or, since it can be, submit, okay, but it would be nice to have a single repository, right? The most updated. And I do notice recently, for example, the tunneling code showed up a couple months ago, right? That's good news. Yeah, but it's still a lot of features, right? So it's also, openvSwitch.org is kind of staging before, because kernel.org, it's not really controlled, by the people here. Okay. Yeah. Okay. Yeah. So user kernel dependencies, right? Maybe this part, user kernel dependency is a issue that one has to manage for any of the system, feature involving a tool in the user space. So next bullet item is the first feature we added. Actually, Bill added. When we started with 1.7.1, and you may notice that the way the tunnel setup is, it requires one vPort per traditional IP tunnel, meaning the source or the local remote IP address, and it doesn't scale with if you have many remote hosts. So we fixed that. We create something called dynamic tunneling. And the semantic is here, one vPort per GLE key, and then and also this is the way we done it, with one GLE key per vPort is important for resource isolation, preventing DOS attack from different traffic from different virtual network. Then Bill and I noticed recently that the newer code from the openvSwitch.org actually introduced something called flow-based tunneling, and we are sort of in the middle of trying to figure out, what are the differences and how do we combine or merge or whatever, right?
I have not yet had a chance to evaluate the difference, and I think I think high level, it looks very, very comparable, but I haven't dug into the detail, and I suspect there are a few tweaks we could probably make to the flow-based tunneling to make it better for us.
So the next thing about the one we wanted to improve is the flow setup overhead, which is, I noticed on the main list, seems like everybody is aware of this, and there's been a lot of effort. Well, unfortunately, I only noticed it recently in the upstream. So what we did is, we actually notice this problem from two aspects. One is, we immediately, so the old 1.7.1 base kernel, the flow table is a full match based on 5 tuple. And so every new flow TCP connection will miss the kernel cache and will require upcall and go to flow setup all the overhead. And we all know that the HTTP, as a protocol, is a usually short-lived connection, right? So this doesn't fly well with that kind of protocol. And another issue is it actually open up the DOS attack if somebody DOS you with many different file tuples. So this showed up in also the benchmark TCP/CRR. I think the upstream also folks discuss try to measure using the CRR and with L4 match, full match. If I measured without the VM, only in the tab going through OVS versus the IP tunnel, and it's like 10% the performance of the native. So the solution we came up with was we had special mode to add the L3 table flow match in the kernel. Then Bill and I noticed there's this mega flow introduced in the recent upstreams. So we will have to understand how does that work and how does it fit with our need.
Yeah, you also left out the other little embarrassing thing when we actually hooked this up to our guests. We were seeing more like, was it 1K flows? Yeah, 1K flows per section, because the guests had connection tracking compiled in, and some interaction between that and all the other pieces slowed them way down. So all kinds of ways to screw yourself here.
So that was our own issue in a sense, right? Connection tracking is known to be unpleasant for the most part. I'm wondering, in the OVS case, is that built in? Can we get around that? In the Linux case, I believe Eric actually has some fixes in the stack case to make connection tracking more reasonable. So I don't know if those have been accepted, but we would want those to get accepted. So connection tracking is like insidious, and I think that when it slips in, tracking anything at L4, we have to create a state per connection in addition to the TCP states. That in itself is sort of expensive. But the other point here is this is the CRR, which is the test that's doing connection setup and teardown at a rapid rate, kind of emulating a web server. This is not slow path for us. This has to be considered part of the fast path. We can't have this slow. So a 90% performance hit obviously is something that we have to address. So we'll talk about that this afternoon then? Okay, great.
Yeah, and it turned out the connection tracking thing was because of a policy, a separate policy where they didn't want any loadable modules in the guests, so they had to compile all the features in the base kernel. And for connection tracking, being compiled in turns you on, and which is also a bad idea, but that's a whole other story.
Also, I have an impression that the L3, we have to do full file tuple match in the kernel to be open-flow compliant. Because user can specify any kind of so this is like this denominator, common denominator.
Yeah, the L3 only flow thing I did as a prototype was essentially just to evaluate what the performance delta was, and we kept that in reserve in case it was needed in performance in our early deployments. It turns out it hasn't been so far, but it's something we're keeping an eye on. We want to pick up mega flows.
Yeah. So. No, yeah. So. So in a way, in order to be compliant, maybe one have to detect, right? If the user configuration SDN is only L3 using L3, and once they configure L4 mode or rule, you have to disable L3 and go to L4 dynamically, right? I have slides later. We want to actually match, for example, TCP flags, but so make this whole thing more messier. Okay, so ideas about. We also have ideas about how to speed up flow setup. Basically, can we invent a better, more efficient interface for the replacing NetLink? But I have some claim that NetLink is not the issue, so I'm not sure. Also, we created multiple NetLink sockets, and I noticed, there's been active work going on to multi-thread vSwitch. That work. So nice to meet you, Jesse. I just noticed your name. Is that work completed or not? Still going?
Well, I mean, kind of the framework is master.
Uh-huh.
It's going to be a process that's continuing to optimize.
Okay.
But, yeah,
But actually, it's been multi-threaded.
yeah.
Okay.
Yeah, I mean, I'm sure you're involved there.
Sure. Okay. So next is another thing. I noticed actually I got caught by this PSNG discovery was deprecated, and at some point I was downloading latest openvSwitch.org bits and trying to test on the latest option Linux kernel, and I got by this. This fragment bit is not set, and the PSNG discovery is no longer there. My performance number was not good. I didn't notice until a couple of weeks later. It's all fragment packets. And number of this PSNG discovery is really important, especially for testing, right? A lot of people who are outside the kernel land or whatever, they don't know or forget to manually lower the interface NTU. So I wonder, I went to the main archive. I saw somebody, or maybe Jesse or somebody said, well, why we deprecate PSNG is because it doesn't work very reliably and we can simplify the code. But personally, I think this is a very important feature. It doesn't need to be reliable. IP packet is not reliable, but eventually it will get there, get the ICMP back to the TCP connection. Yeah. Well,
So, yeah, I don't think that the goal, I think definitely having some way of automatically adjusting the MTU is still a reasonable one. The reason why PathMTU discovery specifically was deprecated is because it was kind of it was a hack, to be honest. Because it was essentially doing L3 PathMTU discovery on L2, which is... Yeah, I mean, it did work. But I mean, my hope is that there's more, I guess, standards compliant or normal ways of doing it, either through things like MSS clamping or, I mean, you think that's messier than this?
I think MSS clamping is messier than doing. Okay. Yeah, MSS clamping is messier in some ways. It interferes with anything that's potentially doing packet checksums. As secure checksums. There are a bunch of
the goal
ways
is
to do
to
that.
have this automatic, right?
Right.
So I don't know what.
Also, MSS clamping doesn't work for anything except TCP. MTU discovery is for IP.
MSS clamping is not automatic, right? It's manual, right?
No, it's automatic. It rewrites TCP header, TCP options. In the SYN, there's the MSS option, and then the middle box inputs in the clamp shrinks the MSS option in flow, and there's complicated checksum.
Okay.
For a TCP packet, it should effectively end up with the same result as those.
Okay.
But yeah, it definitely only applies to TCP and not other IPs.
Okay.
So anyways, I mean, so I was the one that originally wrote that thing, the one that I think moved it.
So you need to find it.
So I would definitely be open to finding some way of doing this. My hope is that maybe we can find something else.
Yeah. Yeah.
So TTL is. Yeah. So TTL is another thing we noticed, actually more in line of the DOS attack. So somebody can use the same file tuple, but just tweaking or vary the TTL, then create a lot of more flow entries, right? For the same file tuple. I wonder what is history, but I noticed the OpenFlow spec has that thing in, so maybe it's for that.
Yeah, it's probably for that. It's also used in some places. For example, if you're inheriting a ETL from an inheritance packet to a whole calculation packet. When it does the flow setup, it can map on that and set the appropriate ETL.
But it doesn't need to be in the match key. It needs to be inherited.
If you do that, it takes more flow to use.
Okay.
But as far as the video actually, it is like the mega flow stuff. Because on a basis, you're not matching.
Yeah. Okay. Yeah. So some of the DOS attack, the issue has gone away thanks to the megaflow introduced recently. So another issue we noticed was the GSO packet on the first miss, right? GSO packet will get fragmented before sending up. So we were trying to fix this because up to 64K, so it's up to 40-some packets getting up call, right? And we were a little worried about, especially for UDP, somebody, if I don't remember the current code support UFO. If it does, right, then somebody can do a UDP attack on the large packet and then, generate a magnification effect because they could cause 40-some, mob call and packet going up. And traffic isolation. So we were wondering what is the strategy for us. We can use a different separate data path or OVS instance. Eventually, we offer one NavLink socket per vPort, and on the ingress side, for GLE, we have one vPort per GLE key. And at the same time, we can apply some rate control, but then there was a discussion internally about applying at the user level or kernel level. There's a trade-off between them, and yeah, so now to move to the ugly part. So the ugly means it can sort of make it work, but it's really ugly. Architecture, it doesn't fit. So we have a requirement to use OVS. We need to have a firewall NAT support. I actually spent almost more than a month trying to retrofit the IP tables, NAT filter, to work with the OVS kernel, and it's ugly. I think it just, architecture, it doesn't fit. The interface between the two are not the same, and moreover, I discovered I was relatively new to, I never look at IP table code, kernel code. Then after a while I realized, okay, so I actually got the stateless part, the simple NAT or something working. But then when I tried to do content tracking, the kernel crashed right away. Then I realized it has a dependency on IP stack. It has this, reliance on the IP route entry or something. Then I went to look at how does IP, the Linux bridge and EB tables work on Linux bridge. And I noticed there's a really ugly hack. They fake up some structure in order for this not to crash. From this conference, hopefully we got the stakeholder together to figure out, if there's any hope for this, to actually have native support inside OVS kernel for the NAT firewall. We have actually a requirement internally to support this. So another approach people brought up was to allow match in the kernel on the TCP flag. And then I went to look at the latest code with the Megaflow. It doesn't seem to have extended the software key, the key. So the key is still not including the header, the TCP flag. But moreover, it looks like there's a restriction in the key, the mask has to be contiguous, right? So this may be because the matching need to be, the lookup need to be very efficient in the kernel. I don't know. We can find out the reason. Okay. And the second one, well, I guess I'm, how much time? A couple minutes more? So the GLE, I also find out, it kind of doesn't fit with the other features, nice feature from the upstream kernel. So Eric Tumizak, so GLO code is there. GLO stack support the general TCP UDP packets, but doesn't, it didn't support GLE packet until Eric here added support. But when I look at very closely, I realized he did the aggregation after the GLE decap. And then I realized I cannot apply that to OVS. It just doesn't match. But the good news is I actually spent a couple weeks fix. So this has been fixed. And hopefully, I have great numbers, performance number. So this is GLO, GLE support. So basically, the GLO stack will recognize the whole GLE packet and try to aggregate. Hopefully I can find the time to send the upstreams as soon as possible. I have a few more, let's see. I have a bunch of performance numbers, and it relies on me not having to run VM. So I wrote this nice, simple utility that will, I think there's probably some similar thing done before. This will twist two tab devices together, so I actually can run on the IP stack on the same. Well, anyway, the diagram shows how it works. So yeah, I can use more minutes, but
yeah, I'm sure you could. Okay, thanks, Jerry. Very interesting stuff.